Barchan dunes are small, standalone, crescent-shaped sand dunes. They are a prominent feature of sandy river mouths, including this one found near the mouth of the Koichab River on Namibia's Skeleton Coast, near Tora Bay. Barchan dunes are highly mobile, driven by wind. They can sometimes be seen moving upriver in ranks, like this assemblage of Barchan dunes found roughly 10 kilometers up the river from the coast. Barchan dunes move at impressive rates. In another region of Namibia, Barchan dunes moved on average 40 meters per annum or more. In other areas of Namibia, the rate of movement can be more than double that. In Namibia, Barchan dunes are formed as part of a cycling of sand between rivers, ocean, and interior. Flowing rivers carry down a stream of sandy sediments, ultimately to be deposited into the ocean at the river mouth. Longshore oceanic currents then move this sand along the coast. In Namibia, the Benguela Current moves these deposits from south to north. Wind and ocean currents then move some of this sand onshore. Here, the sand can form into hummocks, stabilized by Psammophilous plants. Such hummocks are common near river mouths along the Namibian coast. Here are the coastal hummocks near the Koichab River mouth. Notice how they are stabilized by vegetation. In Namibia, nearly all rivers are ephemeral, that is, they exist mostly as dry riverbeds. When coastal hummocks continue to be exposed to strong offshore winds, this will blow some sand deposits back into the riverbeds. There, Barchan dunes will form and migrate back upriver, driven by offshore winds. This dynamic movement of sand is germane to the question of the diverse tenebrionid fauna of the Namib, which Charles Koch attributed to the presence of a, quote, common and continuous ancient system of dunes, which later became discontinuous, close quote. This hypothesis was taken by others to imply the Namib's ancient lineage, even to claims of the Namib being the world's oldest desert. The dunes in Namibia are indeed scattered and discontinuous. Most prominent, of course, is the massive dune sea of the central Namib, sandwiched between the Koichab River to the south and the Koichab River to the north, which has the Orange River as its principal source of sand. Between the Koichab and Orange Rivers, the dune fields are smaller and discontinuous. North of the Koichab, aside from the coastal dunes between the Koichab and the Swakop rivers, the Namib is virtually devoid of dunes up to the Huab River. From there, the numerous ephemeral rivers are accompanied by small and scattered dune fields, up to the Kunene and Koroko rivers, which demarcates the northern extent of the Namib Desert. Mobile Barchan dunes are an important means of dispersal of sand-dwelling beetles. One tenebrionid beetle genus, Lepidocora, was designated by Charles Koch as ultra-Psammophilous, that is to say, it is an obligate sand dweller. The genus Lepidocora is widespread through the southern and central Namib dunes. The distribution of species is disjunct, however. 3 species, Argentogrycia, Kahani, and Portai, are found in the dune sea of the central Namib. 3 other distinct species, Pelosa, Discoidalis, and Eberlandii, are also found in the southern Namib at isolated dunes such as at Bougainfels and at Grillenthal, just south of Luderitz. These beetles are also found in the central Namib, probably seeded by northward migration of sands across the Koichab River. Species migration does not go the other way, however. The central Namib Lepidocora are not found in the southern Namib. Species migration is from south to north. It does not go north to south. The role of Barchan dunes in dispersal can be found in the species occupying Barchan dunes hiving off from the small dune field at Bougainfels. The species occupying the Barchan dunes that originate at Bougainfels are virtually identical to the species occupying the parent Bougainfels dunes. None of the central Namib species, in contrast, are found in these Barchan dunes. Clearly, the northward migrating Barchan dunes are conveying species northward as they move. Given the speed of migration of the Barchan dunes, this population of southern Namib lepidocora will reach the central dune sea in about 1,500 years by some estimates. Once there, they will enter the already diverse lepidocora fauna of the central dune sea with its vast sandy habitats. The evolution of the lepidocora points to a dynamic interaction between dune habitats and beetle speciation and diversity. In all likelihood, there was a past period of more widespread sand deposition in the southern Namib. This was accompanied by a widespread distribution of Psammophilous beetle species. Changes in climate, as well as changes in river flows, may have led to a reduction of sand into the Orange River, with the resultant depletion of sands in the southern Namib that exists now, leaving behind isolated pockets of sand that could serve as habitat. The isolation led to the diversification of the southern Namib lepidocora. As the dune fields disappeared, Barchan dunes were hiving off the remnants, transporting habitat, and the beetles occupying it from the southern Namib north again to reunite with the ancestral population. Thus, the diversification of the lepidocora is not due to an ancient and unchanging Namib, but to a dynamic interaction with climate and sand transport that builds and depletes sandy habitats, and moves habitats along with beetles through northward moving Barchan dunes. Turning to the northern Namib, with its patchy distribution of coastal dunes associated with river mouths, a similar dynamic points to a pattern of isolation, adaptation, and redistribution known as pocket speciation. Here, again, the dynamic and changeable nature of the Namib dunes plays an important role. At some time in the past, this region was probably covered by a more extensive dune sea than is presently the case. At this time, there was likely a widespread distribution of Psammophilous beetles, such as Onimacris or its relatives. For similar reasons to the southern Namib, changes of climate, winds, and ocean currents caused the depletion of these extensive sands, forming the present scattered set of coastal dunes associated with river mouths. This isolated the populations from one another, leading to the evolution of ultra-Psammophilous species that were tied to dune habitats. Something like this may explain the present distribution of the white darkling beetles to the north. As sand movements picked up again, these newly evolved ultra-Psammophilous species were carried up into the interior, where they could now merge with the Psammophilous species remaining in the remnants of the interior dunes. Again, all this posits a dynamically and rapidly changing Namib, not the continuous and long-lasting stable dune habitat posited by Charles Koch.